Okay, what you see there is the signal generator, the function generator, and it's set for 1000 hertz, 1 kilohertz. You see it fluctuates a little bit because the fine gets you so far. So call that 1000 hertz, 1 kilohertz. Now I also have it set at 5 volts peak to peak sine wave. Okay. Okay. Now, the big thick vertical line, I need a pointer. In the middle, across the horizontal, that's 0. Okay, so it's going 5 volts peak to peak. That's plus 5 volts at the top. So it goes down to minus 5 volts. Alright, and the time base, which is the horizontal, time is left to right, right? Amplitude is top to bottom, is set at 0.2 milliseconds. Now it's milliseconds per division. These are all per division. Each one of the little squares on the grid, that's one division. Okay, so if you go from the far left to the middle, that's 1, 2, 3, 4, 5 divisions. Each division is 0.2 milliseconds, and frequency is 1 over t. Okay, t here being 1 millisecond, 1 over that. This gives you frequency. There's your 1 kilohertz. Okay, so our frequency generator, frequency-wise, agrees with our test equipment. Right, so it's very important up front that you know what you're working with as far as source power, source energy, source voltage, source current, however you want to term it. Your source is correct and that you understand it. Now, there's a voltage called root mean square, VRMS. Okay, that is the voltage that you're going to use for the voltmeter. That's what you're going to read with the voltmeter. Okay, VRMS is the square root of 2 times your peak voltage. This is 5 volts peak to peak, so you say 5 times the square root of 2, and that gives you your VRMS. Now multimeters are pretty much set up, configured to read the RMS voltage. Okay, now that's what I have over here. Do you see the 3.54? If you multiply 5 times the square root of 2, that gives you 3.54 volts. Okay, so you can use the voltmeter to set the amplitude on your signal generator. So it's very, it's not very precise. Okay, so you can use your VRMS to say, okay, you do the calculation, what do I get? So, to prove it to you, let's say I crank that up to 10 volts, okay, 10 times 0.707, which is the square root of 2, should give me 7 volts RMS. So I'm going to crank up the amplitude. Okay, so first thing I'm going to do is I'm going to set this down to 5 volts per division. Okay, 0 plus 10 plus 5 minus 5, 5 volts per division. Okay, and then I'm going to change the amplitude on the signal generator. So I'm going to go to the next division up, right? Because it's 5 volts per division, so 2 divisions is 10 volts. Okay, and you look at it, it's like, well, yeah, it's about 10 volts, but how do I know it's 10 volts? Well, that's where you use your multimeter. Okay, so it's close. It's 7. Not quite. So then I come over here. I'm going to crank up my amplitude. So I get 7.07 volts. All right, close enough. So you'll see, you really don't see any difference on the oscilloscope. There you go. All right, at 1 kilohertz, time base hasn't changed. Okay, the time base for division. So now I've got 2 cycles, 1, 2, because it's perfect kilohertz. All right, maybe a little bit more. No, you see where it crosses over 0 at the end there? So I've got 1 cycle, 2 cycles. So if I crank the time base up to 0.1 milliseconds, we should just see 1 cycle. See if I got it right. Very nice. There's your time base. Let me zoom out a little bit. Okay, there's your time base. That's at 0.1. Okay, channel 1 is at 0.5 volts per division, but the probe tip multiplies times 10, so that makes it 5 volts per division. Okay, and there's your waveform. Okay. You ground it. Okay, and you can do your position, X, Y. So we're going to put it right in the middle. Okay, turn that back on. It's triggering. It's called trigger level. Okay, you can set your trigger level. See how it changes the phase? That's the phase. You know about the phase. So I get the phase to be right at the 0 there. Okay, and then you can use your XY position to put it right at 0, 0 there. Well, it's a little bit off. That should be right across the crosshairs there. But this is an old junky oscilloscope, but it gets you really there if you want to be. Okay, so maybe I said that wrong. Well, it's still down. Now it's crossing the center, but it's down a little bit. So it's not perfect, but it's pretty good. So what I do is I like to set my trigger level, so that's the front end there is right at the 0. Okay. Let's change the time base back to 0.2. Yeah, not quite. So maybe the frequency generator is off, maybe the oscilloscope is off. We don't know. Okay, but this becomes part of your input data. Okay, this is what my source is. What's off? Is the frequency generator off? Is my test equipment off? And then you've got, I know there's different ways that you can measure what the differences are. There's terms for that. You probably know better than me. Alright, so that's the video on setting up your source voltage. So let's go ahead and crank it back down to 5 volts peak to peak. So what was that? 3.54. So I go back down here. Alright. Oh. Up a little bit, just a tad. This is tough. Alright, there you go. And you see the voltage is down on the oscilloscope. So let's crank it back up to 2 volts per division. So now you have 2.5, 1, 2.5, 5 volts peak to peak at 1 kilohertz. Alright. And that's all.